performance
Good
results.
morning, everybody. The title of our paper is SCLUMD at the Medico task, Transfer Learning Based Classification of Medical Images. My name is Rahul Gupta, and we have three other collaborators from University of Maryland College Park and Qualcomm. Quickly jumping into our approach, we use transfer learning to address the tasks with limited data availability. Our idea here is that medical image classification is a pretty challenging problem, and one of the challenges lies in data collection. Since we have real world patients here, it's not possible to collect millions and billions of images. So the idea that we had was that can we use existing data sets with lots of images and transfer learned models for the task of medical image classification. So in summary, for this transfer learning, we obtain representations for medical images using state-of-the-art deep learning classification schemes trained on huge amounts of data. Specifically, we use the VGG16 architecture and Inception V3 architecture learned on digit classification or real-world ImageNet dataset with huge amounts of data. And then at some point, we obtain features from these VGG16 and V3 networks and then train a supervised machine learning algorithm on the learned representations, and the supervised learning is done on the limited amount of data for the task of interest at hand. So we'll talk about how we obtain the representations for medical images. So first, talking about the features and how we extract them. We have the baseline features that were provided as part of the task. So they were discussed during the task introduction. So we'll just skip the description of baseline features. The next features that we added were based upon this VGGNet architecture. So we have this diagram of the VGGNet architecture on the right. So as we can see, going from left to right, we have several convolutional layers of different dimensionality. So starting from 224 cross 224, we end up at a convolution of 14 cross 14. And then finally, we have a few fully connected layers. And then the final softmax is the predictor for class. So for the case of our medical image, we first trained this VGGNet on large amounts of ImageNet data. And to obtain representations for the Medico challenge images, we have the image go through all the convolutions and take the output of the first fully connected layer here as a representation for the image. So for all the images, 8,000 images in the Medico challenge, we take the outputs from the first fully connected layer as our VGGNet features. We have Inception V3 base features where we have a very deep network here, and we train it on, again, several large data sets, and then obtain representation from the final fully connected layer here in blue as features obtained from Inception V3 base features. Talking about what kind of model we use, so we, as I mentioned, we extracted three sets of features: baseline features, VGGNet based features, and Inception 3 based features. We use a supervised support vector machine classifier here, and the SVM classifier is trained on various combinations of these input features, and it's trained on the Medico dataset, so it is the dataset of interest. The supervised learning is done on the dataset of interest. The hyperparameters for this SVM classifier are tuned using cross-validation on the training set. So we did a tenfold cross-validation to choose the kernel and the box constraint value for the SVM classifier. And about what exact combinations of features we use, they are mentioned in this table over here. So we tried three different combinations of baseline plus Inception V3, baseline plus VGGNet, and all the features combined. And as we can see from the results that the best value is obtained by the combination of three features. We obtain an F1 score of about 85%. And so another interesting thing for us to look at was how the confusion matrix looked like for the best system. So again, the best system was a combination using all the features. So here we see that mostly we perform pretty good for all the classes, but there are two classes which share a lot of confusion, the class 3 and class 5. So there's a lot of confusion where normal Z-line goes into esophagitis and vice versa. So this is one thing that we aim to address in the future, and maybe look at our features and try to address this confusion to improve the results even further. Coming to what we learned from this task is that, first of all, it could be really helpful for tasks with small scale data to use transfer learning, because there are a lot of strong models trained on very large amounts of data, and then they could be useful in training models. So our hypothesis is that since the BGGNet and Inception tree were trained on large amounts of data, they learned to map a large variety of geometrical patterns in the images. So given an image, they could produce a representation for different geometrical patterns, and that is what happened with the Medico challenge as well. One other experiment that we did using cross-validation on the training data showed that just the baseline features obtained gave a accuracy of 72%, which was far less than what we obtained using the other two features. So maybe the hand-tuned baseline features are not as useful as the CNN-based features in this case, and this even further supports our claim that transfer learning could do better when compared to custom features in tasks like Medico challenge with small amounts of data. So in conclusion, we show a model which obtains Matthew's correlation coefficient of 82.6%. And specifically, we obtain a lot of confusion between two classes that we aim to investigate. And the future work would involve, as I mentioned, reducing the confusion between the two classes. We also want to understand the discriminative power of the feature sets individually and what they contribute towards the final model. And we'd also like to use more recent models like GoogleNet and ResNet, and even GANs to further improve our results. Thank you.
So you just got two answers. Yes, they work. Global feature will improve it. So yeah, this was our winner, basically presentation. So thank you very much for attention.